Welcome to Chapter 1, Section 3, Types of Data. Key concept in this section is that the subject of statistics is largely about using sample data to make inferences about an entire population. As we've already discussed, a lot of the time it's difficult to actually access your entire population, and so we use samples as a way of ease, really, to collect data. And then we use that data to make inferences about the entire population. So it's important that we understand all the definitions that are going to follow in the coming slides. First one is what's known as a parameter. A parameter is a numerical measurement describing some characteristics of a population. The way I remember this is both of them start with P. Population and parameter go together. And all that a parameter is, again, is a numerical measurement that describes some characteristic of a population. In contrast, a statistic is a numerical measurement describing some characteristic of a sample. Again, sample and statistic both start with S, so they're fairly easy to keep them straightforward. And again, this is a numerical measurement describing some characteristic of a sample. Now to introduce a couple of different types of data. The first is quantitative data. Quantitative is also known as numerical data, and it consists of numbers representing counts or measurements. Example, although not a great one, the weights of supermodels or the ages of respondents. Both of those things would be numbers, and they would represent either counts or measurements in numerical form. The next type of data is what's known as categorical data. It's also known as qualitative or attribute data, and it consists of names or labels representing different categories. So some examples of categorical data are gender, male, female of professional athletes, and another example is shirt numbers on professional athletes' uniforms. Those numbers, although in football they also indicate position, are usually substitutes for names, and so we call them categorical, or again, attribute data. When working with quantitative data, it can actually be broken down further into two different types, discrete and continuous. So let's look at each of those types. Discrete data results when the number of possible values is either a finite number or a countable number. So, for instance, the number of eggs that a hen lays. A hen can't lay 1.25 eggs. They either lay 1 egg or 2 eggs or 5 eggs. So it is a countable number in the sense that it is usually a whole number. And again, this is discrete data. In contrast with discrete data is continuous data. And continuous data is somewhat similar to what it sounds like. It results from data on a continuum. So there are infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, interruptions, or jumps. So when we looked at discrete data, we talked about hens laying eggs and that a hen can only lay 1 egg or 2 eggs. It has to be a whole number. In contrast with that is the amount of milk that a cow produces in a given day. So an example of that would be 2.343115 gallons per day. The amount of milk that a cow produces can be broken down into a very, very precise number. And on a scale ranging in weight for how many gallons that, or volume in this case, how many gallons that a cow is going to produce in a day, you can imagine that there is a very large, infinite number of possible values that a cow could produce. This concept of discrete and continuous data can definitely be a bit of a challenge. So if anybody wants to go over this further, please do let me know, because I know that this is a place where people get a little stuck. Okay. Another way to classify data is to use what are called levels of measurement. So let's go through those. The first is the nominal level. The nominal level of measurement is characterized by data that consists of names, labels, or categories only. and the data cannot be arranged in an ordering scheme. So for example, in nominal, survey responses could be coded as yes, no, or undecided. Yes and no and undecided, there really is no particular order. And again, it's characterized by names, labels, or categories only, and there is no ordering scheme. In contrast with that is the ordinal level of measurement. This involves data that can be arranged in some order, but the differences between the data values either can't be determined or don't really mean anything. So an example of that would be course grades. We know what A, B, C, D, and F are, and we know that an A is better than a B, and a B is better than a C, and so on. So again, this data can be arranged in some type of order, but the differences between them are not really the point. Okay, another level of measurement is what's called interval. The interval level of measurement involves data that can be arranged in order and where the difference between any two values is meaningful. However, it is important to point out here that there is no natural zero or starting place. And what I mean by that is there's no point in which none of the quantity is present. So a good example of an interval level of measurement is time. There is really no consensus on when time starts. And so the years 1000, 2000, 1776, 1492, we can put them in order, and we understand that the difference between the year 1000 and 2000 is 1,000 years, and we have a concept of what that means. However, there is no natural zero for time, or at least certainly not one that everyone agrees with. So time is a good example of an interval level of measurement. The ratio level of measurement is the last level we'd like to discuss. And in this level, it has the additional property, so it's very similar to what we just saw with interval. However, there is a natural zero starting point. And that zero indicates that none of the quantity is present. So for values at this level, differences in ratios become very meaningful. So a good example of that would be the price of college textbooks. If you pay $0 for your textbook because you're able to borrow it from a friend who took the course previously, that represents no cost. So again, there is a zero starting point. And if you bought a book for $100, that book costs twice as much as a $50 book. So what the ratio level allows you to do is to be able to compare and contrast two different levels, which is different than the other levels that we previously have discussed. So here in summary, here are the levels of measurement. The nominal consists of categories only. Ordinal consists of categories with some order. Interval, the categories have differences, but there's no natural zero point. And in ratio, there are differences and a natural zero point. Okay, that wraps up section 1.3, types of data. On to section 1.4.